Hello everybody. Now we shall discuss about Maxwell's inductance capacitance bridge. Maxwell's inductance capacitance bridge. Now let me draw the Maxwell's inductance capacitance bridge. Let E is the AC voltage applied to this bridge. R1 is the resistance of this resistor. L1 is the inductance of this inductor. R2 is the resistance of this resistor. R3 and this is R4 and this is C4. The current which is flowing through this is I1. The current which is flowing through this is I2. Current flowing through this is I3. Current flowing through this is I4. Current flowing through this will be IR and this will be IC. IC. Okay. Now voltage between these two points or voltage across this branch is E1. Similarly, voltage across this branch is E2. Voltage across this branch is E4. Voltage across this branch is E3. Under balanced conditions, under balanced conditions, Z1, Z4 is equal to Z2, Z3, right? Okay, what is Z1? Z1 is R1 plus, I'll do one thing. Okay, under balanced conditions, Z1, Z4 is equal to Z2, Z3. What is Z1? Z1 is R1 plus J XL1. R1 plus J XL1 into what is Z2? Z2 is R2. Okay, R2. What is, sorry, Z1, Z4. Z2, Z3, right? Okay, what is Z4? Okay, Z4 is R4 into 1 by j omega C4 by R4 plus 1 by j omega C4, as these two are in parallel. Parallel combination of these two impedances is nothing but Z4. Okay, so R4 into 1 by j omega C4 by R4 plus 1 by j omega C4. What is Z2? What is Z3? Z2 is R2, Z3 is R3. So R2, R3. R1 plus j omega L1 into, this will be R4 by 1 plus j omega R4 C4, which is equal to R2, R3. R1 R4 plus j omega L1 R4 is equal to R2 R3 plus j omega R2 R3 R4 C4. Equate both real and imaginary parts separately. Then you're going to get R1 R4 is equal to R2 R3. Equating imaginary parts, L1 R4 is equal to R2 R3 R4 C4. Then R1 is equal to R2 R3 by R4. Then L1 is equal to R2 R3 C4. Okay, now in both balance equations, R2 R3 are common. Okay, if you vary R2, this shows effect on R1 because R1 is in terms of R2. Okay, so we should not vary R2 R3, R2 R3. Okay, if I vary R3 or R2 in this equation, then this shows effect on R1. Okay, so you vary R4 and C4. So if we choose R4 C4 as variable elements, then the two balance equations are independent of each other, or independent of each other, independent. Okay, so choose R4 and C4 as variables. So now here you choose R4, C4 and R4 as variables. Okay, now R1 is unknown resistance, unknown resistance. L1 is unknown inductance. R4 is standard variable resistance. C4 is standard variable capacitance, and R2, R3 are known non-inductive resistances. Okay. Now let us take R1 and L1. R1 is equal to R2 R3 by R4. L1 is equal to R2 R3 R2 R3 C4. Okay, what will be quality factor? Q factor. Quality factor Q factor is equal to omega L1 by R1, which is equal to omega R2 R3 C4 by R2 R3 by R4. Then Q is equal to omega R4 C4. Okay, Q is equal to omega C4 R4. Okay. Now fixed capacitors, fixed capacitors, capacitors have high degree of accuracy, high degree of accuracy than variable capacitances, variable capacitances. Variable capacitances, capacitors are standard variable capacitors are very expensive. Okay. Now here see, if you want to measure high Q coils, R4 should be more. R4 should be more. Okay. So measurement of high Q coils demands high value of resistance, high value of resistance, that is high value of R4, resistance R4. Okay. The resistance boxes, the resistances boxes, normally we use decade resistance boxes. Okay, the resistance decade resistance boxes of such high values are very expensive, or very expensive, or very expensive. Okay, so this bridge cannot be used for the measurement of high Q coils. It is not suitable for the measurement of high Q coils. Okay, high Q coils, measurement of high Q coils demands high value of resistance R4. Okay, the resistance boxes of such high values are very expensive. Okay, so this bridge is not suitable for the measurement of, so bridge is not suitable for the measurement of high Q coils, high Q coils, that is, it is not suitable for the measurement of Q greater than 10. Okay, it is not suitable for the measurement of Q greater than 10. Okay, so high Q coils cannot be measured using this bridge. Okay, measurement of high Q coils cannot be measured using this bridge. Okay, coming to low Q coils, what about low Q coils? Q less than 10. Is this bridge suitable for the measurement of, sorry, Q less than 1? Okay, very low Q coils. Let us see whether this bridge is suitable for the measurement of very low Q coils or not. That is Q less than 1. Anyhow, this bridge is not suitable for the measurement of high Q coils, that is Q greater than 10. Okay, here see Q less than 1, that is very low Q coils. Okay, here see fixed capacitors have high degree of accuracy than variable capacitances or variable capacitors. Okay, so uh, and one more thing is variable capacitors are very expensive. Okay, so it is advisable to use fixed capacitors than variable capacitors. Okay, so sometimes what we do is we use fixed capacitors. Actually, we have to use variable capacitors here. Okay, if I use fixed capacitors, that is if I use fixed capacitor C4, if I don't use variable capacitors, okay, then we have to vary R2. In order to obtain balance condition, we have to vary R4, R2 and R4. Okay, so we are going to get difficulty in balance adjustment. If I choose R2 and R4 as variables, because of not using variable capacitor, if you don't use variable capacitor, if you use fixed capacitor then variable capacitor, then I should vary R2. But if I vary R2, I can't make these two equations independent of each other because R2 is present in both equations. Okay, so if you vary R2, that shows effect on both R1 and L1. Okay, sometimes see if you use fixed capacitor, we should vary R2. Okay, by varying R2 and R4, it is difficult to get balance conditions. Okay, so there will be difficulty in balance adjustment. Okay, because of difficulty in balance adjustment adjustments adjustments this bridge is not suitable for the measurement of very low Q coils, that is Q less than 1. In order to achieve high degree of accuracy, we are supposed to use fixed capacitor then variable capacitors. If I use fixed capacitor, then it is difficult to obtain balance conditions. So because of difficulty in balance adjustments, okay, this bridge cannot be used for the measurement of very low Q coils, that is Q less than 1. So this bridge is used suitable for the measurement of this bridge is suitable for the measurement of medium Q coils. In some textbooks it is low Q coils, that is 1 less than Q less than 10. Okay, coming to the advantages, after completion of advantages and disadvantages, I'll draw phasor diagram. I'll draw the phasor diagram for Maxwell inductance capacitance bridge. Two balance equations are independent of each other, independent of each other, or simply independent of each other, if we choose if we choose R4 and C4 as variable elements or variable elements, the frequency term is not present in balance equations. Okay, so two balance equations are independent of frequency. Independent of frequency. This bridge bridge gives simple expressions. Simple expressions. Expressions for R1 and L1, unknown resistance and unknown inductance. This bridge is used for the measurement of a wide range of inductance at power and audio frequencies. This bridge is used for the measurement of wide range of inductance. Coming to disadvantages. This bridge requires a variable standard capacitor, which may be very expensive. So the cost of this bridges cost of the bridge is more. This bridge is not suitable for the measurement of high Q coils. This bridge is not suitable for the measurement of high Q coils. Now let us draw the phasor diagram. Okay, now let us draw the phasor diagram. Let us take current as reference vector. Let us take I1 as reference vector. I am taking I1 as reference vector. This is what I1 which is equal to I3 under balance conditions. Under balance conditions, no current is flowing to this detector. Then I1 will be equal to I3. Okay. Now let us draw voltage across R1. Voltage across R1 is in phase with I1. So okay, voltage across R1, okay, voltage across R1 is in phase with I1. So this will be I1 R1. Okay, now let us draw voltage across L1. Voltage across L1. Voltage across L1 leads current through L1 by an angle 90 degrees. So voltage across L1 leads voltage across L1 leads current by an angle 90 degrees. So this will be voltage across L1 leads current by an angle 90 degrees. So this will be I1 omega L1 voltage across L1. Now fair sum of voltage across this and voltage across this gives E1. Okay, so fair sum of these two, voltage across R1 and voltage across L1 gives what? Gives E1. E1 is equal to E2. E1 is equal to E2. Okay, right. E1 is equal to E2. Okay. Now this part is completed. E1 is completed. Okay, E1 is fair sum of voltage across this and voltage across this. Now let us draw E3. E3. How can I draw E3? E3 will be in phase with I3. So E3 will be in phase with I3. So this will be E3. So this will be E3. E3 which is equal to I3 R3 which is equal to E4 which is equal to voltage across this is equal to voltage across this, that is IR R4 equal to IC by omega C4. Okay. Now E3 E4, E3 is equal to E4 here. This phasor is E3 is equal to E4, E3 or E4. This phasor is E1 E2. What is E? E is fair sum of E1 and E3 or E2 and E4. So fair sum of I'll do one thing before drawing that. Let me draw I2. Okay, I2 you're going to get, I mean anyhow, I2 will be in phase with E2. So let me draw I2 like this. So which will be in phase with this E2. So this will be what? I2. This will be I2. Okay. Now how can I draw IR, current flowing through this? IR will be in phase with E4. So let me draw IR. Sorry. Let me draw IR here in phase with E4. So this will be IR. IR. How can I draw IC? IC leads E4 by an angle 90 degrees because E4 is the voltage across C4. So current through the capacitor leads voltage by an angle 90 degrees. So this will be IC. Okay, now E is the phase sum of E1 and E3 or E2 and E4, right? So phase sum of these two, phase sum of E1, sorry, phase sum of E1 and E3, E3 or E2 and E4 is what is E. So this will be what? This will be E. E. This will be E. Okay, now here see. I4 is the phase sum of IC and IR, right? Okay, so I4 is nothing but I2 only. So this will be I4. Okay, now phase sum of IC and IR is nothing but I4. Phase sum of IC and IR is nothing but I2 or I4. Okay. Thank you.